So now that we have in mind all these rules and best practices to do event-driven architecture, don't you think it would be like awesome to have a real-life example at scale? I think it would. And since event-driven architecture is all about building blocks, who better than two Lego engineers to talk about that? So this year, Sheen comes back along with Clara to talk about their experiences at the Lego group. So please give them a round of applause.
Okay, good morning. Who was here last year? Quite a few. Okay, nice to see you again. And welcome back, everyone. Last talk, Luke's talk, was like a serenity, right? So it felt like, early winter's day, you sit by the side of the window, watch the snow falling, so quiet, because snowfall is quiet, right? But it creates an impressive and impactful landscape, or the snow land. That's sort of the feeling I had when Luke was talking about event-driven architecture and the serenity of how we kind of pitch the whole thing. Anyway, so this is a different story, okay? And so it's a dual act between myself and Clara. So happy to see all you here. There are 4 AWS heroes here today, a developer advocate from AWS, bunch of AWS community builders, and many experts from other cloud platforms. So please make use of the opportunity to interact and learn from each other, because you only hear 7 or 8 stories here, but there are plenty of stories out there. So make use of the space. Right, my name is Sheen Brisals, and I'm part of the Lego group. And last year, I was talking about sustainability in serverless. How can you bring the sustainability thinking into your serverless development? But today, it's about enterprise adoption of serverless. So how an enterprise can move to serverless, use event-driven architecture, and what some of the the best things that need to be thought of before an organization gets into serverless. So we'll go through those sort of things from our experience today.
Hi everyone, I'm Clara Villa. I'm one of the engineers at the Lego group. I did join technology 5 years ago, I think now, as a business analyst / product manager. And then last year, I took a bootcamp in engineering, and I transitioned to be an engineer on the payment service. So, welcome to the talk. Disclaimer, I do talk very, very fast when I'm very excited. So if I do that, please wave at me and stop me. So there's 2 common questions when I say we, I mean Sheen, really, get asked. The first one is everything at the Lego group serverless? The answer is no. The technology department is massive. We cover everything from manufacturing, brand retail store, website. So every team pick the technology that works best for them. So we do have a data center, we have container and Kubernetes. I like saying Kubernetes. I don't really use it. But yeah, so there are other technology out there. You might wonder why we're here. Then it's because Sheen and I belong to a department that does use serverless. We are called Marketing Channels Technology, MCT for short. And our department has a different area. So we cover Lego.com, all of it, front-end, back-end, platform, 360 degrees. We also cover store operation. Here we are. So if you go to a Lego brand retail store, everything that makes it run, it's us. And we also cover consumer service. So if you phone up to make an order, or if you want to use the chatbot on the consumer service website, that's also our team. So that brings us back to our second common question, which is, how much of Lego.com is serverless? I'll let you be the judge of that. We went serverless in July 2019, and this is a high-level architecture of our website. So I'm going to walk here. You can see on this side, it's going to be the F word. So we do use Fargate and container to host our front-end React app in GraphQL. But if I walk back to this side, and if my animation works, the brain of Lego.com is all microservices and Lambda, and then a lot of other AWS services. You will see all the icons. We will go into some details later on. How did we get to serverless? So, to tell you the story, in 2017, November, we were still on the old legacy monolith technology. Big campaign, lots of traffic came to the website. The legacy platform failed us. The website went down, panic and fire all over. So we decided nobody have to live through something like that ever again. So in 2018 spring, I joined the team. I didn't make it to the slide though, because more important, our team started experimenting with serverless, and they moved from experimenting to actually build things in serverless, which brings us to our July 2019 when we were fully live with the new Lego.com on serverless. At that time, there was roughly 20 engineers. They were split in two main teams, front-end and back-end, or integration team, as we called it. The integration team used to sit in the same area of the office, so business analyst / product manager, we used to running around and ask them questions, and it was well known as, I'm taking a trip to Land to find out what's going on. After going live, we didn't sit still, so we created another team to work on a new payment service and a new payment provider integration, which was rolled out in autumn 2020. And from there, we kept expanding, we kept getting traffic. So by summer 2021, we realized that peak traffic was not really a thing anymore. It was peak traffic basically every other day, because we have product launches like once a month, sometimes twice a month. We have marketing campaign. There's always something going on. Never a dull moment on Lego.com. So the team had to grow and expand, and we grow and expansion. You also get stakeholders asking new feature. So we kept growing and growing and growing, until today, where we have roughly 25 product squad, tons of microservices, multiple AWS account, and so on. And this is us. I'm going to hand you over to Sheen now. I'll talk to you later. Don't go anywhere.
So growing from, say, simple 10, 20 engineers, 2 teams to 25, 30 squads doing serverless and a bunch of things, how is it possible? One thing that you hear in the industry is serverless first, right? Because serverless first, serverless mindset is always there. That sort of hurries people to get into serverless, get head first into serverless. Let's do everything serverless. So soon you see that the serverless first becomes serverless must. You don't think anything, you dive deep, do a bunch of things serverless, Lambda all over the place, and you get into a mess. Then one fine morning, you hear from a video publishing company that, serverless is not good, let's move over to somewhere else. Then the entire cosmos, downs on serverless, and serverless, practice being looked at a cult activity and all sorts of things. This is all because they forget the fundamentals. Before we get to serverless first, there are few other first principles that we need to think of. The first one is domain first. Domain first. This is the typical domain-driven design. So if I remind you the MCT, the marketing channels technology, Clara talked about, is split into domains. I'm not going to name them, but domains. And then you know what comes next, right? So you have the subdomains. You have the split of various subdomains, core domains, the typical DDD in your organization. Then soon you get to the important part of finding your bounded context. So this is important because this is what defines the boundary for your, the smaller space, application or a service or platform or however you term it. Once you have the boundary, it becomes easier to assign ownership, because when you have boundary, you need people to protect. This is when API first thinking comes in, events come in, because these sort of boundaries, they are apart, they don't kind of mess around with each other, they have protocols to communicate. And when you have ownership defined, it then becomes easier to build your microservices or applications or apps or everything else within that sort of boundary. So this is kind of the approach we have. We will talk couple of, how a couple of teams develop serverless soon. So this is one of the main practices that we follow, that if there is a new need to set up a new product development, immediately a small two-pizza size of team gets formed, and they get the autonomy to run things on their own. If it's a microservices, backend, serverless, they operate with their own AWS account, the APIs, events, all sorts of things come into the picture. So that means, so here is an example of a particular squad that kind of forms that, that sort of pattern. So that is Clara's squad.
I'm the example. So serverless payment. The 2020 milestone we just saw, it's about this. So a bit of history. Before serverless payment, well, do it. Sorry, wrong button. We had different business units in the Lego group. There were needed transaction with payments, so everybody was integrated with their own payment provider. Sometimes it was the same payment provider, but because all the business unit worked in silo, we had several integrations with the same provider outside the Lego group. So we decided that was not very smart, so we created unified payment API, which is called BrickBank, because we like funny names. As you can see, the whole idea is like the payment API has lots of clients, and that could be anywhere in the Lego group. Lego.com was our first client, but then we integrate with Lego Education, consumer service, B2B, and so on. So the point is, like, whoever needs a payment, come to us, and then we are the only person, the only thing they need to integrate with, and it's our responsibility to integrate with payment provider and provide payment method. That being one payment provider, several payment provider, it's our problem. So as a client, you don't have to worry about any of this. We do integrate with several providers to provide different payment methods. So you have some example. We have different credit cards. We have PayPal. We also have Apple Pay and so on. Who's the team, which is my team, that support this? We're called Breakcoin. You can see a little theme there about money. We have our own AWS account. We have our own separate repo from the front-end app, for example, which is called BrickBank. And our design principles are API first and event-driven architecture. So you can see we fit in this talk. This is some of the things that are inside our BrickBank service. I'm just going to point out the number of event bridge rules is over 40, and it keeps going up. And just to give some context, here we have some metrics about traffic we get per minute. Just bear in mind, this is payment traffic. This is not Lego.com. So if somebody comes just to check out what we released yesterday because they were asleep when we done that, or somebody decide I'm going to add this in the wish list and wait for payday, none of this is reflected in these stats. This is just payment transaction. A sneak peek what's inside the repo. A lot of microservices. And I'm going to point two of them out because they will be useful later. Data pipeline and push notification. So remember those names. And over back to Sheen.
Thank you, Clara. So if any of you are interested in how do we do payments with serverless, Luke is here. He's the lead engineer of the squad. So plenty of serverless knowledge. So please interact and make use. So how do we build? So we talked about domains and all the split and everything. How do we build the stuff? How do we take this forward? So that's where event-driven architecture comes. So you heard plenty from Luke earlier, so I'm not going to go into detail. So by now you all know what CDA is. It's basically events, performing the show or communicating or making things happen. Now, in simple terms, if you're completely new to EDA, there are few important parties. So there's a publisher, producer, or source of the event. Then on the other side, you have subscribers or targets. And then you have the events, of course. Then the middle, you have the broker or carrier or bus, or there are different terms used. What is an event? It's something already happened. So this is kind of the cliche, the typical definition you find. But what helps is have your mindset bit relaxed when it comes to identifying events. So you hear about domain events as the main events that move around between the different domains. That's fine, should be there. But also, when you work within your bounded context or boundary, there will be other types, categories or events like operational events. So if you're keeping a service watch on a third party, And if you want to notify the third party is down, that is an event that is only important to your kind of boundary. It's not something relevant to other domains, maybe. So similarly, there will be internal events and events you transform before you send the targets. These sort of the event types will get. Then you have, if you are working on AWS, you have AWS events. So adding more complexity, you will also come across with these sort of event types. I'm not going to go through the details of these event types. So these types are also possible when you work within your ecosystem. I'm not going to argue, but you can take all these learnings to your team, and you can argue, that has to be a request type of event, response type of event, et cetera, et cetera. So these things are, keep in mind that because these things will come across when you develop event-driven architecture. Right, so microservices. So the next thing that takes the serverless development forward. You all know domain-driven design, mentioned a few times, it's like an industry because even though it's like 20 years old, the book, it's still kind of going strong with the number of books written about it, the conferences, the training courses and everything. It has so many core kind of concepts that are still useful, relevant in our application of serverless development today. The second aspect is microservices. So microservices by definition talks about all the good things about how to build a microservice or a service, right? But typically what happens is people set microservices with a monolith thinking or container thinking, like that's when things originated. But we can take it to the next level. So that's when you breaking down your problem comes. One of the challenges I've seen with engineers is knowing how to break down a problem. If they are given a feature development or service development, they struggle to break things apart because often, if you don't know, then you end up building monoliths. So that's why it's important to think in terms of, the whole picture and also move towards that in parts. So this is kind of something I always preach about is like have your vision as a whole thing, then your focus should be, in parts. So the famous authors also talk about the same thing. Think big, act small. So that's easier to achieve in an incremental and iterative way as you develop event-driven and serverless architecture. So for example, this is a different boundary context, I'm closely associated with these days is a loyalty service. So in a typical bounded context microservices thinking, you probably will think that it's a single microservice. The problem is in a small team, there are a few engineers. If you need to make changes, you all will be stepping each other's toes or making things difficult to push something to prod. So this is where the set piece thinking comes in. So like Clara mentioned, shown earlier, so this is a loyalty service and how we split the whole thing into smaller microservices. These are, even though they stay within the boundary, which is that yellow kind of rectangle, they still are decoupled, event-driven within their ecosystem. So the beauty is that you can evolve this architecture, or you can kind of, sustain it taking forward. Say, for example, if you need to bring in more features or add more services, it becomes easier to, bring those in. So that, takes us to sustainable application. So sustainable application is something that kind of you can evolve and keep it going for longer. It's like the evolutionary architecture. But there are three main characteristics you need to think of: modularity, extensibility, and observability. If you can't observe, if you don't know what's happening in your service, it's so difficult to do anything with it or extend or do it. So that's an important aspect of building services. And how do they communicate? I think by now you all know. So APIs, events, messages. So having this sort of clear boundary and the protocols of communication that keeps things separate and makes the development and serverless development easier and simpler to move forward. Right, so some of the practices we follow, we do solution design before anyone kind of, develops anything. And then we do threat modeling. Threat modeling is basically to trigger the idea or create the idea awareness among the engineers that security is an important aspect. It should be part of development and should be thought of during the design and architecture stage. Then, as I mentioned, iterative and incremental development. It's easy to make, even if you make mistake, easy to come back and correct. So I talk about MVP to MVP, which is like minimum viable product. You can easily take that to make it a maximum valuable product or most valuable product. So that's my interpretation of MVP to MVP. And then observability, already talked a lot. So it needs to be observable. You have all your monitoring and other aspects in place so that you can extend your application going forward. So I hand over to Clara to talk about a couple of event-driven use cases.
Yes. So after all this theory, how does it work in real life? What kind of work? So I'm going to take you through a couple of examples. So the first one is push notification. For once, we kind of got the naming convention right. So this microservices does what it says. It pushes notification out. It started with a very common use case. Shopper comes to lego.com to place an order to get it delivered to their house. So we expect as part of this flow, there's a payment transaction involved. There is. And this is where my team gets involved. The high-level requirement for this use case were to give a synchronous response to lego.com to make sure they can confirm to the user as soon as possible if the order is approved or not, which means we can expose to the front end the bare minimum of payment details, which also means when the order has to be passed to the fulfillment center for fulfillment, they will need additional details. This is the high-level flow. So right here in the middle is our payment service. We have different endpoints that serve different purposes. For this specific use case, we have the payment ones to request payment and the status endpoint to request the status of the payment and all the additional details. The flow starts when lego.com makes a payment request to us that we then forward on to our payment provider and then all the way backwards. So provider gets back to us, we go back to lego.com, and at that point, we basically just tell them yes or no. Your payment is approved or declined. If the payment is approved, then what lego.com does, because they need more details to submit the order, they start pulling our status endpoint to get the details. And this means they do, can I have my details? Can I have my details? Can I have my details? We don't have them right now. So what happened in the meantime, asynchronously, our payment provider send an event to us called payment notification that we then consume and transform and use to update the status. And when the status is finally updated, lego.com stop polling and then submit the order to the fulfillment center. Here we are. You can see in this flow, there's a tiny bit of an issue right here. So polling, because they can't constantly tell us, do you get my details? They have to poll at intervals, which means if you just miss the update, your order is going to take longer to be submitted, which is not the end of the world, but still not great. So we decided to come up with a change, which is surprisingly send an event to lego.com. And this is what we did. And the benefit of it is self-explanatory. There's no more polling, and your order can be submitted quicker. So if you have a look at the flow after we made the change starts in the same way, payment requests coming up and down, and then lego.com just sit there quietly waiting for us. So we still receive our event with a payment notification, we consume it, we update our status, and at that point, we push an event to lego.com to let them know, hey, we got your details, and then they can submit the order to the fulfillment center. So this is the flow. How does it look like in AWS resources? So this big white box is our AWS account. Payments, we have payment provider pushing the event to a webhook, which is our API gateway. When we get the event, we trigger our Lambda, the notification handler, that consume the notification, store in Dynamo, which is our payment table with all the details, and then push an event to our internal bus. This is a custom bus we have in Brickbank. It's called internal because we use it to communicate between microservices and within the function in our service. So it's just for us. Quick note on the notification handler. we receive payment events, so we need to make sure the event comes from our payment provider, and we also need to make sure the payment provider is really the payment provider, not somebody pretending to be them. So we do some validation first when we receive the event before updating the database. So all of this is our payment service. So to start the push notification flow, we create a new microservice, which is triggered by an event. So we listen to the notification event that goes in internal bus. So we have an event bridge rule that says when you get this event type from this source, which is the notification handler, start. And in the microservice, we created a step function. We have step one that transforms the event. And you will be pleased to know we use the envelope. So there's a data part with all the details that the client needs. We have metadata, and we do use a unique ID to help also troubleshooting. Second part, we encrypt the event. So we use the JWT encryption, and then we pass it to the bus. Bus is like my favorite thing. Everything goes in and out of the bus all the time. It's not the same bus, though. So the Q is in the name. This is called external bus. So we created a new custom bus to be used to communicate with our external client, which is opposite to our internal bus, just for us. In this specific case, our external bus goes to Lego.com bus. Lego.com also has an AWS account, which is the different one. So we leverage the cross-account functionality. And we find out during test that you can't just wake up one day and start sending event to everybody else's bus. This bus has to allow you. So there's a permission that you have to make sure you give us. So you say, hey, you're good, send me your event. Otherwise, they get rejected. Once we started with the push notification and we create our external bus, we realized this could be used for other things. So, because we don't see it still in payment, we create another microservice called fraud service. It does what it says. It does a fraud check. So we receive a request, we do a fraud check, and if you pass it or not, we send the result of the check to our external bus again, and then the external bus push it to our client, which is another Lego business unit. And the client doesn't have to be on AWS. So they can just give us a webhook, and we can push the event to them using the event API destination of EventBridge. And this is it for our push notification. It works. Second case study, slightly different context. This talks about integration between the payment service and the data lake. So the use case, very simple. There's lots of payment events in our product. We want to take them all and send them to a data lake so our big data team can create a report for us. Yes, report is coming. Then we can use with our stakeholder to make better decisions, basically. Our high-level requirements, we want to send all the payment events. By that, we mean that different provider can have different shape events with different fields sometimes, and then there's also different step in the payment journey. So you can have an authorization event, you can have a capture event, which is actually when we take the money, or a refund event. So there's different type of payment event itself that we deal with them all. And then the data lake has the requirement to have the event sent to them in batches. And then the data lake is clearly not in our domain, so the data has to be exposed to an external client. For that, which is called Big Data Pipeline microservice, we did a couple of iterations because it was the first time we did something like that, so we wanted to make sure it worked and then add on. MVP type of concept. So this is how we built it. You would recognize this. This is the same internal bus we just seen is our BrickBank internal bus from the payment service. And funnily enough, we listen to the same notification event. Exactly the same one. So we built event bridge rule that listens to the notification event, and then we'll trigger our new big data pipeline microservice, which has a step function, surprise. The first one is called store event. It's a very simple step function. What it does, takes the event and transform it, because the big data team has requirement on the number of fields they want, the name of the fields, and the format of the fields. So we do some transformation to package it in the way they want. And then we store it in an S3 bucket, which is called event log bucket. So the event comes in, gets transformed, and stored there. And this is our internal bucket, basically. At the same time, we leverage another feature of EventBridge, which is the scheduler. So we create a schedule event that runs every hour and trigger another step function that we call query events. So what we do with this one, we use a Lambda to create a query string. So it takes the timestamp of the event and does some string manipulation. So it can be used by Athena to run a query. We use Athena query to query our event log bucket, and the mapping between the two is done with Glue catalog. And when the query runs, the results gets put in an S3 bucket, which is a different one, which is our report. I can't say this word properly. Repository bucket. And this is the bucket that the big data team is going to use to fetch the data. So we need to make it accessible by creating this VPC access point. And the data lake can come and fetch the data whenever they want. The reason why the arrow is going this way is because we let the data team decide how often they want to fetch the data. So it's not us pushing it to them. They can come and fetch it like once a day, once an hour, whenever they want. A couple of details that will be useful later. It's not a quiz, but you might want to remember those. We encrypt the object that we store in the event log bucket. So we create a key in a key management system in AWS. It's a custom key that we also share with the data team so they can decrypt. And then we created this string, this pattern for the object name. So when the event comes in, we store it in the bucket with this year, month, day, hour, / object ID, to kind of create a pattern that helps Athena query. So when your Athena query runs at 10 o'clock, for example, we make sure we only fetch the event that's been saved in the event log bucket between 9 and 10. So we make sure we just fetch the newest event and there's no duplication. We started all of this with just one type of event to make sure we could build the whole pipeline and the event were landing in the data lake as expected. So iteration 1.5 was to add more event. And because the events come from different provider, they might be slightly different in terms of number of fields and name of fields. So what we need was a different transformation. So we added, obviously, a rule to listen to more event. And in our first state machine that stored the event, what we did is adding a choice at the start. So when the event comes in, there's some logic then says, hey, which type of event are you? A or B? And then we send you either left or right, which also means we have to create a second Lambda transformer to transform the type of event in the right way. The end result doesn't change. So all the event comes in, then it goes in the right transformer, and it gets spit out, I can't find another word right now, in the S3 bucket as before, and which means the second part of the service didn't have to change. After that, we went live. We've been live for a while, and then to quote one of my old engineers when I was a product manager, we hit a bit of a snag, which is kind of a nice way to say something is on fire. In our case, it was cost. We found out there were like two main causes of spike in our cost. One is the call to the S3 bucket and the KMS. So if you remember, we were saying we encrypt every event. We get tons of events, like several per second. So there was tons of calls, and every call to the S3 bucket require a call to KMS to fetch the key. So we have a bit of a spike. And then the second one, this is my favorite, is the Athena query. Because you remember we had this nice thought-through path for our object name to make sure you go and fetch this last hour event. Well, S3 doesn't do folder. So the nicely path that you created is not a folder in its head. So what Athena has to do is literally query every single object in your bucket until you find the object name which match the query string you passed in the query. So as you can see, the more event we have in the bucket, the longer is the query, the bigger is the query, the bigger is your bill. So we had to stop the service for a bit, and we went back to the drawing board, and we make a couple of changes. We decided to batch the event, to be put in the S3 bucket, and to use Athena partition to make the query more efficient. Spoiler alert, it actually worked. This is our cost graph. So clearly you can see when we went live, right? And then to let you know, we went back on May, and you can't even see the spike anymore because the costs are like significantly low. Quick check of the architecture, how we did that. In the first state machine, we're not putting the event straight to S3 anymore. We're using Kinesis firehose. So Kinesis batch everything for us. You can set up parameters for time and size. So whichever it gets first, then it will move the event to the destination you set, which is our S3 bucket. And then in the second state machine, no new resources, but in the Athena query, we introduce the partition. And this concludes our second case study and wrap up our talk. And I might be running out of time. Apologies, everyone. So very quickly, remember to embrace the change. Technology is changing to make our life easier, so just go and do it. Remember to follow your boundaries, make sure nobody step on each other's toes. And there's also best practice out there. One of them is the well-architected serverless standard. You can follow them to make sure everything works.
Yes, thank you. Thanks, everyone. Thank you. Sorry.
Thank you very much. Sorry.
Thank you very much.
I think we took over time, so please, find us if you have questions, and we can, always have a chat after. Thank you.
Thank you, everyone.